0, algebraic summation of all this, and from that we get the first equation. There is no contribution for this vertical weight along horizontal direction. For y direction, these are the individual components. SCB sin theta 1 upward positive, SCA sin theta 2 upward positive, and 1600 multiplied by 9.81 approximately 16,000, not G is equal to 10, that's that. Anyway, around that 16,000 Newton or 16 kilonewton, it has that contribution along y direction negative, vertical downward. So these are the three components along y direction. These are the three components, this plus 0, and right hand side it will be 0 for this satisfying the resultant is equal to 0. And we solve it, we can go for two unknowns, solving these two, which are the tension developed in these two members, BC and CA. Now next thing, all earlier things, it is very easy, simple, and we can understand very easily. Now, three forces are there, so they can form for equilibrium a closed polygon. Now what about that shape of the closed polygon for three forces?
Triangle.
A triangle naturally, and one is given completely. This one, a vertical downward force, almost 16 kilonewton, it is there, and we can represent on a paper by a length whose, by a straight line whose length will be proportional to this magnitude, around 16 kilonewton. Okay. Now what about the other two vectors or other two forces? Whatever may be the magnitudes, direction definitely you have to follow this angle theta 1 and this angle theta 2. So there will be two lines except this one, the given vertical force. One will be parallel to that angle theta 1, other will be parallel to that angle theta 2, and they will pass through these two terminal points of the 16 kilonewton vector. Through this point, we can draw a line parallel to that angle theta 2, and through this point we draw a line parallel to the angle theta 1 and get this point of intersection. Now this is the starting vector 16 kilonewton. Then from this point we move to this location along this angle theta 1, and definitely it will be the force in that member BC, and represented by the capital S with subscript CB. Now BC and CB, they definitely are the same member, but as we are talking about this joint or this particular location, so from this point we start naming the members CB, and this is CA. So when we are talking about a triangle having one side given completely, other two sides with the angles theta 1 and theta 2, then definitely these lengths, the segment of this straight line within this location and this location, this length is proportional to the force developed in that rope CB. And this is the force developed in that member or rope or string, whatever it may be. That force will be SCA, proportional to this length, and the scale with which you have drawn this line to represent this 16 kilonewton, we use that scale, and accordingly we find the value of the force in the member CB and value of the force in the member CA. Now tell me, is there any confusion, any problem?
No, sir.
Okay.
No, sir.
So at least
Okay,
from
sir.
here, we can understand the application of your standard 8, 9, 10 in your schools, that drawing a triangle, that is a straight line given with its length and direction properly. Other two sides, their relative angles with this straight line given are given. So draw a straight line. From this point, draw a straight line parallel to theta 1, and you do not know where to stop. because you do not know the magnitude. So you draw a straight line and extend it up to a certain reasonable position. Then from this point or through this point, draw a line parallel to that member CA. Now, when we draw this line, extend it so that it intersects with the previous line, this is the very important location. This is the terminal point. So that vector SCA, or that member or the force developed in that rod or rope or string, from this point to this point, this is the length representing the magnitude of the force developed in the member CB, and we can use the scale whatever we have selected. If 1 centimeter represents 1 kilonewton, then corresponding to this 16 kilonewton force, we need 16 centimeter length. If it is possible to accommodate in the white page, then it's fine. Otherwise, we can scale it down a little bit. Suppose 1 centimeter represents 8 kilonewton, 2 kilonewtons, suppose. So how much length you need there to represent 16 kilonewton? It is 8 centimeter. Now in that way you can scale it down or scale it up so that a suitable length can be placed there to represent the magnitude of this vector. But one thing, not only this one, but other forces also you have to consider, and their angles also. So this is the very basic geometrical way. And why we start with this geometrical? Because it is easy to understand and we can easily feel that physical representation of that situation in that way. And this geometry is the oldest chapter of mathematics. And so many things. Now can you tell me what is the value of pi?
3.14.
3.14.
22 by 4.
Now how do you know this thing?
3.14.
Sir, by drawing
How do
1
you know
centimeter diameter circle and finding the circumference.
Yes, sir.
Now how do you know this thing, value of pi?
Read in books.
It is written
Sir,
in
we
book.
can,
A
sir,
book
we
आपने
can,
लिखा है?
Teacher told.
sir, we can do estimation by making regular sided polygon, and the higher the number of regular sided polygon sides, that is, like it should be a multiple of 8, and then we can find its circumference and then divide by the uh, line joining two opposite sides. That way we can approximate pi.
Now, when it was told that value of pi is approximately 22 divided by 7, when? आपने तो नहीं किया ना, कुछ सीनियर्स ने जरूर किया होगा. So what is that?
The circumference of a circle divided by circumference diameter of the circle.
Yes, sir. Circumference by diameter.
Yes.
Circumference by diameter. But किसने किया है? आपने तो नहीं किया ना, मैंने भी नहीं किया.
Yes, sir. I did not want.
So even we do not bother about those people. Those are the big contributors for this subject, the great people. और वो लोग पागल थे. कुछ भी हो जाए, we need to find out the truth. We need to find out the reason why it is happening. Why that length versus diameter, it is a almost fixed value. छोटा सर्कल लो या बड़ा सर्कल, ultimately maintain तो ही करना है. But when we started understanding this thing, because we had those mad peoples. Anyway, मैं तो उतना पागल नहीं हूँ, दिमाग थोड़ा सा खराब है. Anyway, मैं आप लोगों को थोड़ा पागल नहीं, आप लोगों को पागल नहीं बनाऊंगा, नहीं. So this simple thing, physically we can understand that this length is little greater than this length. So the force in the member CB will be more than the force in the member CA. But we do not know really which value they have. Only thing, when we convert from this scale, that this 8 centimeter length represents 16 kilonewton force, then multiplying with that same scale, measure in centimeter, multiply with 2 kilonewtons for each centimeter, we get these forces. Okay. And name this thing. This is the terminal point. Erase this extended part of this line. Erase this extended part of this line and put proper unit. This is in Newton. SCB, that should also be in Newton. And this is SCA. Now, before going to our next pattern of discussion, not topic or chapter, next pattern of discussion, I'll just try to discuss about the solution of this problem. Now, what about the force applied here? It is horizontal. Its magnitude is not given in that way. One mass of 16 kg is hanging. Directly, the force is mentioned. 660 Newton force is there. And supporting members are AC and BC or CA and CB. Here also, the inclination of these members are not given. We need to find it, and how to find the angles made by these members with the horizontal. If it is angle theta 1, then what about tan theta 1?
3 by 2.25.
3 divided by 2.25, both in meter. And
Yes.
what about this
Yes.
angle?
1.4
1.4
divided by
1.4 by
2.5 meter. So find out theta 1 and theta 2 from inverse tan or arc tan. Then determine the sine values and cosine values. The forces in this member CB and in this member CA, those are not known. So multiply these forces with the sine theta 1, sine theta 2, cos theta 1, cos theta 2, and include this force in the suitable equation. This force will be present there in its full form, 660 cosine 0 in sigma fx is equal to 0. And it will be absent in that sigma fy is equal to 0 because 660 Newton multiplied by cosine 90 degree, that is 0. Now, from the second equation, we can get a relation between SCA and SCB. Now, replace one with respect to the other in the first equation, where 660 is there and only one unknown will be there. Solve it, replace that value in the second equation, and it is very simple. That you know from your basic algebra of your school. I don't need to repeat these things. But here, how to physically understand this solution? You draw a line maybe of 6.6 centimeter, as if 1 centimeter represents 100 Newton. Now, from these two terminal points, suppose this is the horizontal line, here is the terminal point. From this point, draw a line parallel to this angle theta 1 in that way. Now, how to draw? In our some previous class, I discussed about that. Just simply use two set squares. Hold one set square, matching one edge with this straight line AC. You hold it firmly, then you bring another set square, place it freely, matching that edge, and then you slide with this firm edge of the set square hold in your left hand. When you slide it, the sides will be parallel to its original position there, and we can shift this straight line to some other location. Anyway, I'm not going to discuss that set square business in detail here. You please give a random search in Google, that Google or any other engine, that how to draw parallel lines using two set squares. बेटा बहुत सारे देखने का चीज मिल जाएगा. Okay, now you just concentrate on this diagram. You forget about this 1600 multiplied by 9.81. You forget about this name HCB. You forget about this ACA. It could be better if we could copy this thing and erase these things. Anyway, let me give 1 minute. I'll do that and come back. Now, do you find that screen again shared on your
Yes.
screen? Now, what is that? It is that same previous diagram, simply erasing these names. Okay. Now, this is a triangle formed by 3 straight lines. It may be of given length, may not be, but any rough way of drawing one triangle is like that. Now, I need to finish one important job. What is that? Definitely you know. To take your
Attendance.
Attendance.
nice beta.
Attendance.
Now again. Now, if there is a line, it is given. Then you do in this way. Arbitrarily, you select this point and draw a line connecting. Suppose this end is A, this end is B. So you draw a line, any arbitrary line, AB. Then select any point in that plane, point C, and join this line connecting B and C, and draw one more line connecting this point C and A. So what you get? We get a triangle. And for graphical representation of forces, it means that there are 3 forces. One is this, other one is this, and the next one is this. And it is forming a closed polygon, that is a triangle, and there is no resultant. It is a case of equilibrium. Okay. Now, if we change the direction of these arrowheads, instead of these terminal points, we give towards the finishing points as of this construction of this triangle. So one is this point to this point. Okay, you have to visualize that this arrowhead has been shifted to this place, and other one from this direction, this location to this location. Now, what does it mean?
Sir, it gives the resultant vector. The downward vector represents the resultant vector now.
Downward vector is the resultant vector of this force F1 and this force F2. Now, if you think that this vector is given, not the resultant vector, but a given vector, a given force, suppose F is there, and we select another arbitrary location C1, suppose initially it was C1, then suppose it is C2, I rather have to depend on your ability of visualization. I'm not drawing the continuous diagram. Only thing, just think about any location here. It is location C, second location of C, suppose it is C2, and draw 2 lines connecting this A with this C2 and connecting B with this C2, and give those arrowheads from A to C2 and C2 to B. In that case, what happens? The same force is the resultant of these 2 vectors represented by these directed line segments AC2 and C2B. Am I clear?
Yes, sir.
Yes, sir. The angles have changed.
Angles are changed, the shape of the triangle, area of the triangle, everything is changed. But the basic idea that not changed, that we are fixing a particular resultant. It's not like that the forward process, F1 plus F2 is the resultant R. It is some kind of backward process that represents the vector R in terms of any 2 arbitrary forces which can give us the resultant R. So this is one arbitrary force, this is another arbitrary force, but whatever may be, they form a closed triangle, or they form a triangle rather. So vector F1, vector F2 for first case, that is the resultant R. Here vector nu F1 plus vector nu F2, that also give the same resultant R. Now if we consider, now can you find this location here, somewhere in the white portion outside this black area?
Yes, sir.
Can you see
Yes,
the
sir, we
movement
can
of this
imagine.
cursor? Now, if we select any point here, then what happens? We do the same thing, same old thing. From
Yes.
A to new location, third location of C, AC3, we draw a line, put the arrowhead here at C3, and from C3 to B, draw a line and put the arrowhead here at B. So again, this force is the resultant of these two vectors or the forces. The third F1, which is represented by this line segment AC3, and the third F2, that is C3 to B. Now, what is the difference between all these three cases? C1, C2, C3, these are three different locations where we form this triangle, keeping this as the given resultant. That it should be the resultant of any other combination of other two cases. The first case F1 plus F2, second case of F1 plus F2, the third case of F1 plus F2, everywhere we'll get that vector summation as the resultant R. So this reverse process is called resolution of forces. And in most of the books, you will find clubbed in one small area or topic that is called composition and resolution of forces. Intentionally, I discuss about the composition. Of course, it comes first, then discussing about some problem, etc., etc. And I shifted a little bit. Resolution of forces. And you can do it. Now, if we consider a special orientation, suppose we draw a straight line along any arbitrary direction, and or it may be any given direction. As we have solved this problem, this is the given direction θ1. So this is given 16 kilonewton. We draw a line θ1, and now θ2 is not given. Through this point, we need to draw a line because we need to form a closed polygon, that is a triangle. Now from this point, we draw a line perpendicular to this line corresponding to this angle θ1. We draw a perpendicular to this line. Suppose this is the foot of the perpendicular. Now can you mention anything special which happens there?
Periods.
First of all, it is a right angle triangle. Next thing, the force in the member CB, if that angle is not given, only thing the direction of θ1 is given, we have drawn this line, and in that case, if we draw a perpendicular here also, we are forming a triangle, and these two are the components for this, as if this is the resultant. So this is the one force and this is another. But what about this side, which is perpendicular to this θ1 line?
That is perpendicular component of the resultant force.
I'm not talking about the component. You think about your standard 8 level of geometry idea.
Sir, it is lowest, sir, minimum in magnitude.
Pardon?
It is minimum in magnitude.
Exactly. Thank you. It is minimum in magnitude, so that the combinations will give us for this resultant force that one component will be minimum in their magnitudes. So that is a special situation when two are mutually perpendicular. Now there may be so many such important geometrical criteria. Of course, we can write down the vector expressions, the equations, we can solve it. Our computers are also there, just simply feed the those values there, coefficients, we'll get the direct solution. But physically, to have some feel about this thing is very nice, and it can give us from the geometry only. Okay. Now that kind of combinations that we can make, and any such combination we can make for a given vector, we can form a triangle with any arbitrary location of this vertex C, C1, C2, C3, etc. Now, when we are forming this triangle in reverse process, we are resolving this given force in two components, and when it is mutually perpendicular to something like this, these are called rectangular components, and those rectangular components are like this. here for X and Y direction, not necessarily they will be horizontal and vertical. We can take any direction. Suppose the line along the direction of F1, we consider a direction U. And through this point, we draw a perpendicular, suppose that is the axis V. So sigma FU is equal to 0 and sigma FV is equal to 0. That is also true because we are resolving all the forces in two rectangular components, and algebraic summation of components of the individual forces that is equal to 0, and no matter in which direction you are resolving them, getting the component not only along x direction, any arbitrary direction you can find out the component, because even if we select any other line, suppose this is the minus 30 degree, a line is there. So drop a perpendicular, there also, if it is the direction n, so f1n, f2n and the resultant n or equilibrant n, all these components. For resultant, f1n plus f2n, that is equal to rn. For equilibrium, f1n plus f2n plus this equilibrant n, that is equal to 0. So nothing to worry about horizontal and vertical directions. For any direction, you can find their components and make it 0. So all these idea you have to keep it in your mind, so that basic geometry, the composition of the forces, the resolution of the forces, the resolution or components in two mutual perpendicular directions like x and y, u or v, u and v, or n and t, that is normal tangential direction. So all such things are very simple, easy, basic, primary, but you need to do proper practice. Otherwise, during examination, I don't say that you cannot solve these problems, but you have to use more time. And for competitive exams, time is very valuable. For this school or colleges, etc., normally examiners are known. Your class teachers are your examiner. But in competitive exam, the idea is to discard or to eliminate or remove maximum number of candidates where there is a limited number of seats or positions for that particular, whether you are going for master degree or going for some job, there look better to eliminate you. Okay, so please make good practice, go through any book, all these primary and fundamental things, you will get everything discussed in almost in this similar pattern. You go through the solved example first, build up your confidence, you try to put your own signature there, that try to solve the problem with another method or some alternate method. Then you attack the end of the chapter problem. If there is any trouble, we discuss in this platform. Maybe some more intelligent people are there in this class who can help you. Okay, जैसे to give some more sunlight and some more rain. बेटा अभी तो winter season है, rain अच्छा नहीं लगता.